Given this particular matrix, identify the dimensions associated with it. The dimension of a matrix is the size of the matrix. The size is measured by the number of rows multiplied by the number of columns. So let's count the number of rows we have. This is the first row, 1, 2. Therefore, we have 2 rows multiplied by, now it's time to count the columns. So that's the first column and that's the second, meaning we have 2 columns. Therefore, this matrix is a 2 by 2 matrix. Matrices are basically a rectangular representation of linear equations. The numbers that are within a matrix are referred to as entries, and they are identified by the value A, I, J. Now I is associated with rows, and J is associated with the number of columns. So if you are asked to identify A22, which entry would that be? Now A22 is referring to row 2 and column 2. So we are looking at row 2 and column 2. That means 8 is that specific entry. Another operation that you need to be aware of, which is to find the determinant of the matrix. Now let's take the same matrix that we had previously, and that was 2, 4, 6, and 8. To find the determinant, we need to multiply 2 by 8 and subtract it by 6 multiplied by 4. So it would be 2 multiplied by 8, take away 6 multiplied by 4. 2 multiplied by 8 is 16. Take away 6 multiplied by 4 is 24. 16 take away 24 is negative 8. Being able to identify the determinant of the matrix is necessary to be able to identify the inverse of the matrix. Now, given the same matrix, 2, 4, 6, 8, we are told to find the inverse. Now, let's say that this matrix is A. This is the A matrix. To find the inverse, it will be written like this, A to the power negative 1. That is the inverse of A. So let's give each of these entries a symbol or a letter. So number 2 is A, number 4 is B, number 6 is C, and number 8 is D. The inverse of a function can be found by taking 1 over the determinant of A multiplied by D, negative B, negative C, and A. So since we know that the determinant is negative 8, all we need to do now is to flip the A matrix in this format. And that is simple. D, which is 8, will be here. Negative B, B is 4 and it will be negative, which will be here. Negative C, C is 6, and it will be here. And A, which is 2. This is the format of this matrix to find the inverse. Now let's go ahead and multiply it by 1 over negative 8, which is the determinant of A. So 1 over negative 8 multiplied by 8 is 8 divided by negative 8, which is negative 1. 1 over negative 8 multiplied by negative 4 is 1 over 2. 1 over negative 8 multiplied by negative 6 is 3 over 4. And 1 over negative 8 multiplied by 2 is negative 1 over 4. This is therefore the inverse of matrix A. Let's look at some matrix operations. Starting with addition. Matrix A, the same matrix we've had, 2, 4, 6, 8, and matrix B, which is 7, 3, 14, and 21. Is it possible to add these two matrices? The dimension of matrix A is 2 by 2, as we know, and so is the dimension of matrix B. It's 2 by 2. Therefore, yes, we can add these two matrices. When two matrices are of the same dimensions, we can add and subtract them. If they are not the same dimensions, we cannot do that. Now let's add these two matrices. 2 plus 7 is 9. 4 plus 3 is 7. 6 plus 14 is 20. And 8 plus 21 is 29. How about these two matrices, C, 16 and 27, with A, 7 and 2. Is it possible to add these two matrices? Yes, it is possible. These two matrices are 2 by 1. Therefore, it is possible to add them. And the result is 16 plus 7 is 23. 27 plus 2 is 29. How about these two matrices? A equals 1, 0, 2, 2. B equals 3, 2, 1, 6, 7, 8. Is it possible to add these two matrices? Now, this matrix is a 2 by 2, and this matrix, B, is a 2 by 3. They are not the same dimension, therefore, we cannot add these two matrices. It is undefined. So now we know how to add matrices. Multiplying matrices is not quite the same. Say we have this matrix, 7, 6, 2, 15, 20, 23. Right, so this is a 2 by 3 matrix. Say we have another matrix, matrix B. 1, 2, 5, 20, 7, and 11. And this is a 3 by 2 matrix. Is it possible to multiply these two matrices? The answer is yes. In order to multiply two matrices, the number of columns of the first matrix has to be equal to the number of rows to the second matrix. So this determines that yes, it is possible to multiply the two, and we know that the resulting matrix will be a 2 by 2 matrix. We know that the result matrix will be a 2 by 2 matrix. Let's go ahead and multiply these two matrices. When multiplying two matrices, we always go row by column. We multiply each row by each column. Starting with the first row, and that is 7, 6, and 2. We multiply it by the first column, 1, 5, and 7. 7 multiplied by 1 is 7. 6 multiplied by 5 is 30. 2 multiplied by 7 is 14. We add all of those values together and we get 51. This answer goes in here. Now we multiply this same row by this column. So 7 multiplied by 2 is 14. 6 multiplied by 20 is 120. 2 multiplied by 11 is 22. We add them together, and that yields 156. This value goes in here. Now we move on to the second row. We take this row and we multiply it by each column. Let's start with multiplying this row by the first column. 15 multiplied by 1 is 15. 20 multiplied by 5 is 100. 23 multiplied by 7 is 161. We add those values, which yields 276. This value goes in here. We are almost done. Finally, we multiply the last row with the last column. 15 multiplied by 2 is 30. 20 multiplied by 20 is 400. 23 multiplied by 11 is 253. Adding these values yields 683, and that goes in here. We have now multiplied matrix A by matrix B to yield this matrix over here. Let's try another example. Is it possible to multiply these two matrices? Now, matrix C is a 3 by 3, and matrix D is a 2 by 3. No, it is not possible to multiply matrix C and D because the number of rows and columns are not the same.